Alright guys, we're going to shotgun through each video for the Chapter 7 homework. Just make sure we have a good understanding over what we were looking for in terms of the total response for the voltages across the capacitors or for the current through the inductor. So we're going to look at and take a look at each problem. Just make sure you guys have the tools that you need and get your questions answered if you have any. Obviously, give me a shout if you want to do individual video conferences. Otherwise, we can just answer any question on Tuesday or Thursday. Now let's take a look at 7.9. 7.9, basically what we considered a source-free RC circuit. And so basically the switch opened at t equals 0, which we had initially drove current to establish a voltage across this 3 millifarad capacitor. So if we look at the first condition here, t less than 0, that's when we get that initial condition. So the switch was closed, current left, went through the 2K ohm resistor, and then basically we found that the voltage across the cap, that initial voltage, was actually going to be the same as the voltage across the 4K ohm resistor. And so simply by voltage division, V naught was just equal to 6 multiplied by 4K over 2K plus 4K, which gave us an initial condition of 4 volts. Now, when that switch opened, so there's no more excitation that could actually keep a voltage built across the anode and the cathode of the capacitor. And so because that source is completely disconnected, we'll basically just go right through a transient period in which we exponentially die off to 0 volts. So essentially what's really happening, as we've discussed before, is all the energy that's stored in that electric field of the capacitor is being released, goes through, it cycles right through that capacitor, that resistor, and we know that because it takes work in order to get that current through that resistor, that work basically gets converted into heat. And so as basically that energy cycles through the circuit, we see that exponential decay in which basically we die off to 0 volts. Now, very simple problem. Started off easy, right? So here, time constant. Remember, that's R Thevenin times C for the resistive capacitive circuits. So for t greater than 0, we think about the rest of the circuit for which is to the right. The switch is open, therefore 4K, 6 volts, no longer comes into play at all. And so the only resistance that would actually be seen by that capacitor was the 4K ohm resistor. Multiply that by 3 millifarads, 3 times 10 to the negative third, and we still get a value of 12 seconds. And that makes sense because 4,000 ohms is quite a bit, and 3 millifarads is actually a very high value of capacitance. Usually we see it in the microfarad range. So total response, V of t is equal to V infinity plus V naught minus V infinity times e to the negative t over top. So 0 plus, and then 4 minus 0 is obviously being the coefficient of the exponential, e to the negative t divided by 12. Sure enough, we get the final solution of basically 4 volts as a coefficient multiplied by the exponential. We start at 4 volts, we die down to 0. Okay, next problem.